we're going to start with a warm-up here, and we're going to find, given this function x equals x cubed minus 27, the first thing we're going to do is find f of 2. So again, we've been talking a lot about f of 2, just means to simply plug it in. So we're going to get 2 cubed minus 27. And so f of 2 is going to equal, that's going to be 8 take away 27, so that's going to be negative 19. All right, so pretty easy. Now we want to divide f of x by x minus 2. So I'm going to do this with synthetic division. It doesn't say how to do it, so I'm going to choose synthetic because it's easier. So I'm going to do x minus 2 equal to 0. So really what I'm going to use in my synthetic division is positive 2. The coefficients to this polynomial are 1 for the x cubed term, 0 for the x squared term, 0 for the x term, and negative 27 for the constant term. So here we go. Drop down the 1. 2 times 1 is 2. Add them up, you get 2. 2 times 2 is 4. Add them up, you get 4. 2 times 4 is 8. Add them up, and you get negative 19. That negative 19 is the remainder. Right? Just like we got when we divided, or when we substituted in 2 to the function. Now, when you compare these two guys right here will always be the same. All right, will always equal. Now, not only that, but let's say I'm trying to factor a polynomial that I want to graph, and I find out that x minus 2, this implies that x minus 2 is not a factor. So implies x minus 2 not a factor, but it also implies that the point 2, negative 19 is on f of x. Right? So I could use that point to help me graph if I needed to. So what we're going to be doing today is we're going to be looking at something called the rational root term. We're going to be using some of those synthetic division techniques that we just looked at. And the rational root theorem says if a polynomial has a rational 0, right? What does the word rational mean? It means fraction. Okay? So if it has any 0 that's any type of a fraction, and by the way, a fraction could be the number 3 because 3 is always over 1. We can guess at the possible roots, okay? If a polynomial has a rational root, a rational 0, it can be found by checking all possibilities of the form p over q, where p is equal to the factors of the constant term so any number that goes into the constant term. All right, see this number 8 down here? This is your constant term. All right, any number that sits by itself in an equation is a constant. So this is p, and we're going to divide those by the factors of the lead term. Okay, so in this case, q is equal to 1. All right, so now just keep an eye on what we're doing here. Okay, so I'm going to use my example as I talk more about this, but so I have this polynomial down here, and I want to be able to find the zeros of this polynomial, and I need to be able to do that without graphing. So one of the things I can do is I can look at this 8 that's in the back and this 1 that's up front, and so p is going to be all the factors of 8. So let's just start with that. What are all the numbers that go into 8? Well, there's 1, there's 2, there's 4, and there's 8, and there's minus 1, minus 2, minus 4, and minus 8. So I just put a plus minus out front, and I just remember that it's all plus minus 1s and so on and so forth. The next thing, what are all the factors of q? Well, since q is 1, the only factors of q are 1. Now you can put a plus minus down here as well, but when you put plus minus on the top and the bottom, they cancel each other out. I shouldn't say they cancel each other out, but you still end up with only one set of positive numbers and one set of negative numbers. So that plus minus on the bottom doesn't really need to be there. You'll end up with the same numbers. Now, because we're dividing everything by 1, that just means I end up with the numbers in the numerator. So here's the deal. My possible zeros. Okay, so when we say possible zeros, we're talking about x-intercepts or solutions to this polynomial up here. If there's going to be a 0 in this polynomial that's rational, okay, if there's going to be a polynomial that's rational, so a fraction or a whole number, then it would only be one of these 8 possibilities down here. You couldn't have a 0 that's 3 or 5 in this polynomial, because 3 and 5 are not listed in my possible zeros. So, which one do I pick? It doesn't matter. You pick one. All right? Find one that is a 0. Now, there's a couple of ways you could do this. I could just simply start substituting these numbers in and doing some synthetic division, and I could find out, you know, which one works doing that. Or some of these numbers are a little bit easier to plug into the function. In other words, go back to your warm-up for a minute. Remember in the warm-up when we plugged in 2 to the function and we found out very quickly that 2 is not a 0, therefore x minus 2 is not a factor? That's what we want to do here if it's easy enough to do that. So what I'm going to do here is I'm going to take my first one. I usually just go positive 1 first, then negative 1, then positive 2, then negative 2. So I work them down in order. So I'm going to check and see if basically is f of 1 equal to 0. That's the question you're asking yourself, because if it is, then I know that x minus 1 is a factor. So here we go. My function is f of 1. So I'm going to plug in 1 to the function, and that was 1 cubed. So I'm plugging in 1 for the x's right above us, plus 1 squared minus 10 times 1 and plus 8. So if I do my math on that, I get 1 plus 1 is 2. 2 take away 10 is negative 8, and negative 8 plus 8 is 0. So that implies that x equals 1. So when I get 0 there, x equals 1 is a solution, and x minus 1 is a factor. All right? So now that I know that 1 is a valid answer, I need to plug it in. I need to now synthetically divide and break this polynomial down. Because again, the directions said to factor the equation using the rational zeros. Well, I can factor this by a factor of x minus 1. So let's do that and see what we have left over. Okay? So I'm gonna take my factor of x minus 1. All right. So I'm gonna use x equals positive 1 as my divisor. I'm gonna list out all my coefficients: 1, 1, negative 10, and 8. I'm gonna do some synthetic division here. Now I should end up with 0 if I did my math right. So I'm gonna drop down 1. 1 times 1 is 1. Add them up, you get 2. 1 times 2 is 2. Add them up, you get negative 8. 1 times negative 8 is negative 8. And I was right. I got a 0. Okay? But I'm not done yet. I only have one factor to this equation so far, and I know that that one factor is x minus 1. But now I've got some leftover stuff here. My leftover stuff, remember, if I started with a cubic function and I divide out an x, I end up with a squared function. So I have x squared plus 2x minus 8. Now, I could go back and restart this problem all over again and guess at some zeros, and I could get there. I could figure it out, but this is a quadratic. This is easy to factor. All right? This is x plus 4 times x minus 2. So once I get it down to a quadratic, I should know if I can factor that or not. And now I just drop my other factors in line down here. So that problem factors out into 3 different factors. And so it would have 3 different solutions if we were actually going to solve it, which we'll do on another day. Let's try another one. This one's a little bit longer. All right? Okay, so you can see that I've changed the problem up top to match your paper. And so the first thing I want to do is list my P's and Q's. So I've got P's here and Q's here. I'm going to start with the Q's because the only numbers that go into 2 are 1 and 2. But into 16, remember we need plus and minus in the numerator here. So we have 1, 2, 4, 8, and 16 that all go into 16. Now, just for a minute, I'm going to erase the 2 down here. Put the 1 back. But if I was going to divide all of those numbers up there by 1, I would end up with the same thing we did last time. I would just end up with all the same numbers. So I would have plus and minus 1, 2, 4, 8, and 16. But this time there's also a 2 down there. So all of those numbers have to be divided by 2 as well. In other words, take the 1 that's in front and divide it by 2, and that's a half. So I need to add a half to my list. Remember, these are all possible zeros. And then I would take the next number in line, 2, and divide it by 2. Well, 2 divided by 2 is 1. I've already got 1 in my list. I don't need to list it again. 4 divided by 2 is 2. I've already got 2 in my list. Don't need to list it again. 8 divided by 2 is 4. 16 divided by 2 is 8. So I'm done. These are all of my possible zeros right here. And so for 1 and negative 1, I just plug stuff in. All right? Because 1's the easiest number to plug in other than 0. If you plug in a 1 for x, it doesn't change the value of the coefficient in front. 1 to the 4th is still 1. 1 to the 3rd is still 1. So all you end up with are these numbers right here. So all you got to do when you're plugging in 1 is add them up. So we get 2 plus 7 is 9. 9 minus 12 is negative 3. Minus 28 is negative 31. Plus 16 is 15. Oh, negative 15, I believe. Negative 15. So that doesn't work. Nope. So I try f of negative 1. Now the only difference between 1 and negative 1 is if you raise negative 1 to an even power, it doesn't change the value of the coefficient. So negative 1 to the 4th is still 1, times 2 is still 2. Negative 1 to the 3rd, though, is negative 1, and negative 1 times 7 is negative 7. Negative 1 squared is still positive 1. Positive 1 times negative 12 is negative 12. Negative 28 times negative 1 is positive 28. And we still have the plus 16 there. If you add all those up, you get 2 minus 7 is negative 5, minus 12 is negative 17, plus 28 is 11, and 16 is 27. All right? So that one doesn't work. So maybe at this point, instead of plugging in 2, I'm just going to do some synthetic division here. So instead of continuing to plug in numbers, maybe it's just easier for you to plug in 2. So we're going to try x equals 2. So here we go. We list our coefficients. We have 2, 7, negative 12, negative 28, and 16. All right, here we go. First round. Bring down the 2. Multiply by the 2 on the outside, that's 4. 7 plus 4 is going to give me 11. 2 times 11 is 22. Add those two guys up, you get positive 10. 2 times 10 is 20. Add them up, you get negative 8. 2 times negative 8 is negative 16. And voila, I get a 0 remainder. Okay? So right away, before I do anything else, I now know that x equals 2 is a solution, so I'm going to highlight that so I don't forget it. What that tells me is that x minus 2 is a factor. So I'm going to keep that guy right there. And then I'm going to take a look at what's left over in the polynomial here. Now, I already tried 1 and negative 1, so I don't want to try them again. But if you look at what's left over here, this is 2x cubed plus 11x squared plus 10 minus 8. So it's a cubic. It doesn't look like it's going to factor by grouping. So now I'm going to go back to my list of numbers. I've already tried ones. They didn't work. I've already done positive 2. Could positive 2 work again? Yes, it could. But I'm going to try negative 2. Right? So I'm going to do x equals negative 2. So I'm going to take this new set of coefficients here. I'm going to take 2, 11, 10, and negative 8. And I'm going to go to work with x equals negative 2. Here we go. Drop down the 2, multiply by negative 2, that's negative 4. Add them up, you get 7. Negative 2 times 7 is negative 14. Add them up, you get negative 4. Negative 4 times negative 2 is 8, and I get a 0 remainder. So again, I'm going to highlight this guy. I need to make sure I hang on to him. There's a second solution right there. All right? And that also implies that now x plus 2 is a factor of this equation. Let's take a look at what's left. In terms of what's left, I knocked it down from a cubic to a quadratic. This is 2x squared plus 7x minus 4. And remember, all we're doing is factoring here. So I'm going to try and factor this guy. This is going to be 2x. If this is going to work, it's going to be 2x and x. And then I need a 4, and I think I need a 4 here and a 1 here. And the 4 needs to be positive, the 1 needs to be negative. So whatever method you're using to factor, there's 2 factors there, and my other 2 factors there. So the final answer here would read f of x equals, and the order doesn't matter, x minus 2 times x plus 2 times 2x minus 1 times x plus 4. And there's all 4 factors for that equation. All right? Good luck with your homework.
That's all, folks.